joining us. They were summarizing the class after studying the forever cards for a little bit to do the forever quiz tomorrow. Cards 6 through 10, but really 11.
Oh.
Whoa, 6 through 11. But 6 was technically an old card. So 7 through 11, just quick reminder of logistics. 7 through 11, quiz on the forevers, but the bonus comes from old cards, which would be cards 1 through 6. Or I could just check to see if you updated it. Depends on the forever quiz as to what I'm doing. Hint, hint, this one will be an old forever card. Somewhere cards 1 through 6. We have a homework due tomorrow, though, on 2.2b, which is word problem stuff, rates of change stuff, beginning of physics need problems, and applications to word problems with derivatives. So, everybody was summarizing the information like you would do in a homework problem, trying to pick out the most important stuff, and thinking about the situation. So this one, we have a water balloon thrown upward from the top of a building. Mariah asked, what does that mean? Is that coming down and hitting the building? Is that going like across, over, and against the building, like all the way to the ground? What's going on with the water balloon? So, in calculus, and in this level of calculus, I was mentioning how yesterday I was talking about parametric equations. Parametric equations allow us to talk about something going over and up at the same time, all with respect to time. You don't have to necessarily write this down unless you want to just think ahead. So parametric equations say, oh yeah, we can totally have something going up and over at the same time, which is what you're thinking. If you're standing on the edge of a building, which is a little scary, but let's just pretend it's like a railing so you're safe. Sitting against the edge of a building, and in your mind, if you throw it up, it could arc or it could curve. So it cannot just be going up, down, but also out. But in our level of calculus, we're not dealing with parametric equations. We're not dealing with two different horizontal, vertical with respect to time, because to be honest, this two-dimensional motion is a bit trickier. So we're actually saying, okay, that's a CalcAB thing. Instead of doing two-dimensional motion where something is going up and out or down and over, instead we're just doing one-dimensional motion. So one-dimensional motion is, you guys, I know it's weird, but it's going to be like an ideal thing. Because one-dimensional, we're just going to be talking about like y of t. Something going up and down with respect to time, or x of t, something going right, left with respect to time. So we're just going to talk about the vertical or the horizontal, but not both of them at the same time, because we're not going into that two-dimensional motion, trickier derivative stuff. We're just staying basic. We're just saying we only have one equation, or we only have one equation. So in this example, if you're throwing a water balloon off the top of a building with an upward velocity, you're throwing it up, well, it has to be this one. And so at this level of calculus, if we're dealing with a water balloon, it's an ideal situation where the person is perfectly throwing it up and it's perfectly coming down. So there is no out to even worry about. And so in this example too, some of you who are very practical thinkers, this might be a little hard. That's why I'm trying to take some time to explain it. The only reason I know that it doesn't hit the top of the building is because it says down here that it hits the ground. And the only way for it to hit the ground, now I know you could say, well, the ground of the building, I get that. But whenever it's in just a generic problem, it says ground, it means literally ground, okay? If it hits the ground, what happened? Person was standing, there was a railing, they were safe. And let's say they were buckled in somewhere, and they throw the water balloon straight up, and it comes straight down past the building, right? And all the way to the spot on the ground. But I wanted to show you the math as to why I know this example is exactly that way. Does that make sense? So, in real life, how often is it that you throw something, even in like baseball, right? How often is it that you throw it straight up and it comes straight down? Never, right? That's not a thing.
That wind.
Or that you go straight right and straight left. Well, I guess maybe that's a thing. I don't know. Maybe you're talking like a pendulum. It comes like up and it's not just right left. Something on a track. Something's on a track. Maybe it's just going straight to right left. Or like roller coasters at like, I don't know, Magic Mountain or something. Oh no, Superman goes. What's the one that like? Is that Disneyland? Where it pulls you straight up and then it like lets you go. Isn't that on like Pixar Pier? Huh? Yeah. Oh, there's Guardians too. I think the one that like you sit in a circle and then like you're.
The big one? Like at Six
is there 1 to 6? I think they're an 8.
It's dropping.
Yeah, that's so those ones are on a track. Those are straight up and straight down. They're not talking about like your legs going out. Okay, never mind. Real life gets complicated when modeling stuff. So we're just thinking of it this way, doing the basic. So if I'm building, there you go.
Nice.
You have room for my water balloon to go up. And you're leaning out, and you throw it straight up, and then it comes straight down. Now, the awkward thing is, what does the graph look like? Even though it's going straight up and straight down, what would the graph look like? Why is it a parabola? It's not going out.
Because it's going up.
If we plug in 0, wouldn't I have my y-intercept of 80? You guys agree? That's how high. And it's going to go up, and then it's going to go down. Now that's the actual situation, because the water balloon isn't going to literally go into the ground, right? And the water balloon isn't coming from somewhere way over here. You're holding it before you throw it. But why is it a parabola if it's not going out, if it's just going up and down? What do you see?
Well, parabola can curve up and then go down, so it represents.
Okay, Adam's saying, okay, I get that this water balloon isn't going out, it's just going up, down, but a parabola goes up, down. That's part of it. What do you think? How do you label your axes in any sort of graph? If you guys are ever in a chem lab or a physics lab, or like if you have a graph, don't you have to think about what the axes are? Or if you're trying to make a graph, what are the axes? The independent, dependent variable. Doesn't like Mrs. Leon always start with independent, dependent variable in chem? That's so weird. That's math. Oh, but right? Okay, other stuff. Well, and she like walks you out the first door. Isn't it the first day?
No, this is my classroom, not yours.
I actually did that with algebra this year. I kicked him out of my room, and I was like, "Go stand against the lockers." Oh, I was like, "If you want to come to my room," but it wasn't like us being excited. Oh, I did you one day though where I should. All right, so why? What are the axes? X. Well, they call it S, but yeah. In your motion card, isn't it S or X? It's like or. We just thought it could be whatever. But this one's S, and it stands for height. Yeah. Shouldn't you guys have written that down somewhere?
Yeah.
Height. Height colon S of T equals. Okay. So we have height, how high it is, and what's this one? Not horizontal distance. It's time. So if you start a stopwatch, right? Time is moving. What's happening as time is moving? It's going up and it's going down. This isn't the path of the balloon. The balloon's not arcing. The balloon's going straight up, straight down. That's it. One-dimensional motion. We call it rectilinear motion. So why is it curved on the graph? Because time moves. And as time moves, it goes up and goes down like Adam kind of said. Does that make sense?
It was thrown up.
So is this the path? No, we have to be in BC to see the path. Well, let's see the realistic path. The realistic path for us is just kind of boring. Okay, lo siento, but great questions because, to be honest, most kids don't ask that. And then they never have a full understanding. They just think like, oh, it's the path, and they don't even realize this is not the path at all. That's the path, and this is time. Anyway, pay attention to your axes. How long is the water balloon in the air? Pause. What did you guys write down from the whole paragraph as to what was important? Did you write water balloon?
Yes.
Period.
Thrown upwards.
That works. Water balloon thrown upward problem. Sure. What else? You could have written that, or couldn't you have drawn a picture and just put 80? With a little. That's just what I would do. Initial velocity of. Did you guys actually write words for that?
No, I put 64
FT, mean F for S?
yes.
Okay. I would have, if you guys want to think about it this way. Okay, I would do the water balloon problem. I'm a visual person, so I probably would have done something like there's my 80 feet, and then it's going straight up and then straight down. Has an upward velocity. You could do vectors and stuff, but let's not do that. And then I would have said something like V sub 0 is equal to 64 feet per second. Woo! What's the V stand for? What's sub 0 stand for?
Initial.
Yeah, in physics you could do V sub I. In math I don't like to do V sub I so much because it looks imaginary. But V v sub 0, why would I use a 0 as the initial? Initial, isn't that a clue? And not mine starting it right out of room. I was writing too big, it's really tiny. But what's your clue on your forever card for initial? Time is 0. Or you're at the beginning, which could be like 9 a.m., so it might not always be 0. But still, in this one, sure. At the beginning, we can say t equals 0, right? Cool. So I could say v sub 0. I could do v of 0 if you want to do it that way. Either way. Boop, boop. What else is important? Height is 2. And t is since it was thrown. Okay. I mean, I probably wouldn't write that, but that is something good to think about because sometimes they measure time differently. Like time is hours since midnight. Time is, that's talking about waves going in. So sorry, now that we have the important information figured out, anything else that you guys thought was important?
If you wrote down like most of it, is it like points off?
You can. Just think of it this way, John. If you're looking at an FRQ, there are going to be a lot of words. I want your brain to be able to take something that looks really overwhelming and make sure that you have the short, sweet, this is what I'm doing. So it's up to you. Like, I'm not going to judge you for writing every single word in homework. I'm going to be like, oh, I'm not sure if this is the best use of their time, but like I understand some people it's easy for them just to kind of write it all down and their brains are hopefully synthesizing the information as they write it down. It's not all bad. But being able to summarize shows a deeper understanding. For instance, in letter A, if you literally wrote out how long is the water balloon in the air, that's good. And hopefully in your head you're like, oh, hey, it's up and then it's down, right? It's flat. But did anybody think of a mathematical statement, equation, expression that would help us in getting towards the solution as far as processing this question? Do you guys know what I'm asking? Oh, when does the height equal 0? When? Why did Adam say when? It's time. How long? How long does it take for the water balloon to no longer be in the air? If Adam was thinking through height being 0, he's thinking about, okay, well, how long, how much time does it take in order for, aren't we just finding the x-intercept? Or the t-intercept? So I would think of it this way. Ready? Find t such that, or when s of t equals 0. I took the meaning, how long is the water balloon in the air, I thought through it and said, well, it's not going to be on the air when it hits the ground. Oh, hey, maybe I should figure out when it hits the ground, because when it hits the ground shows me how much time has passed since it was thrown, aka how long it was in the air. Does that make sense? And why is my mathematical statement or expression or summary useful? Hopefully. It tells you what to do, right? Because now what do I get to do? Let's go set that guy equal to 0. So that was my mathematical statement. This is what I would do as far as the summary. Now, hold on. If you're in your homework, there might be a reason why you would want to write the words and then write this. Is there ever going to be a time where you write a mathematical statement that wasn't actually what the question was asking for? Yeah, so be careful. It's one of those where it might have been good, like John, what you were saying, it might have been good to say how long in the air, or how long is it in the air, and then write your mathematical statement. I'm showing you what it is, so that's kind of like, oh, hey, no problem, we know what's right, but knowing that how long it's in the air leads to this mathematical statement is a good thing to think about, and something you might get wrong, so you might want to put both in your homework. We need to factor, right, guys? Does anybody realize negative 16 can come out? Can come out, yeah? Because we end up with t squared plus no minus, because I pulled out a negative. Yes, guys, we went over factoring a lot in pre-calc and honors pre-calc the last couple days. I have tricks. I have lots of tricks. Oh. I have tricks. I have lots of tricks, and so factoring is hard for you. Remember my kid that failed algebra 2 and then went on to tutor calculus? I had to reteach her factoring. So it's not a big deal. It's not something to stress about. Just come in, get a whiteboard, we'll do factoring. But I have minus 5, negative 16, but you just need to self-advocate. You can come in and be like, this is what I need. If think you can help me with it, and then say please. Maybe bring me a Starbucks later. But either way, I can teach you factoring if you don't know it so well. Why is factoring so important? What do you get for your t's, guys, for your zeros? Okay, so I get -1 and I get 5, but in these problems we have to be realistic. So realistically, how long was the water balloon in the air? 5 seconds. How did we know that?
Yeah,
The other one, you were holding it in your hand. It wasn't, no, you were holding it in your hand at -1 seconds. You were carrying it up the stairs to the top of the building. I don't know. You're having a competition with friends as to which one, I don't know. Would hit a person? No, that's bad. Don't do that. You could hurt somebody. But coming back. -1 didn't make sense. It was before the thing was even thrown. Mathematically, like on the graph, yes, there would be an intercept of this full parabola, but in all reality of the problem, it doesn't make any sense. 5 is our answer. So what's going on letter B?
That's velocity.
Whoa! They didn't even give me velocity. We should, oh, they did. 64. Done. No, because you're throwing it up with 64 feet per second. Do you guys realize that at some point, that positive velocity is going to be 0 because that upwards motion is going to momentarily stop before it starts coming down. Oh yeah, that's right, because isn't rate slope? What's the slope at the top of any curved motion? 0. So before something starts coming down from coming up, or starts coming up from coming down, what has to be in between? A momentary stop. Very slight, very infinitesimal, but it actually stops at the top of that rate. Well, the vertical motion stops. But so it goes 64, or the upward thrust of 64. But then you're slowing down, because what's acting on that water balloon? Gravity. So you're saying, go to the heavens, and gravity's like, oh, we're pulling them down. Anyway, so he goes up for a bit, and then he comes back down. Sure? So the velocities are always changing. As soon as you throw it and gravity is acting on it and your upwards velocity is being counteracted by gravity in some senses. So long story short, you're going to see the word velocity, but you cannot put 64. It's always changing. So what do we know about velocity? If it does not say the word, if the question does not say the word average, right? If it doesn't say average, where do we always go? Velocity is instantaneous. So we're looking instantaneous. Ooh, I did not spell that right. It was like Satan. Instantaneous. No, instantaneous. We should start it. It should be a thing.
Oh,
that's awkward. That's fun. You can tell I was totally distracted when I was trying to be productive. Not much better than our competition last year. Anyway, coming back. No, instantaneous is not going on our competition. Where is the velocity? We're thinking instantaneous. Instantaneous is the derivative of position. Derivative of position is, oh, we haven't found it yet, but we can because it's easy. It's a power rule. You guys see how it's going to be -32t plus 64? What am I trying to do? I'm trying to take your natural tendency to get to a word problem and just to freak out or to skip it. It's the entire homework, so please don't do that. To be like, oh, take a breath. To be like, it's not that bad. Just break it down piece by piece. We found the velocity function. Wait a minute. Is that all they wanted? Find all the velocities at all the different times? Between 0 and 5 only, because it's only in the air, 0 to 5. No, it just wants one velocity. Which velocity? Do you see the clues? They're everywhere, right? Each of these is pointing to something, either something in the original problem or some sort of concept that you're hopefully getting down. And thinking of the motion of the balloon, starting with Mariah's question, it's perfect. Think of it. It's going up, it's coming down, it's flat on the ground. What is the velocity of the water balloon when it hits the ground? When it hits the ground, it's done, right? Oh, it stops being in the air. Oh, we already found that. That's when t equals 5. So, we're going to plug in 5. Wait a minute. I thought when it hits the ground, the velocity would be 0. Because it hit the ground. It stopped, right? I don't know. Plug it in. See what the math would say. One of the most common mistakes in motion problem is to think that when something hits the ground, the velocity is 0. But it's not. What's the velocity at the instant when it hits the ground? I've just heard a lot of different.
No, I was answering Mariah. She has
-160? Plus 64 is my negative 40.
96.
Oh, okay.
96.
96.
You couldn't read your 9 feet. Whoa! Negative 96! It started with 64! I know, but then what started acting on it? At the instant it was thrown, gravity, right? I mean, gravity was acting on it in your hand, but
So it went like
started acting on it, and then it pulled it down. It had 80 feet to build up speed, which is the absolute value. Why is it negative? Because what was going on when it hit the ground? It was pushing, it was having directed motion towards the ground, down, right? Positive 64, it was headed up. Negative 96, it was headed down. Why does it hit with a velocity? I'm not going to answer that question. This isn't physics. This is Leon. We have a class now. But coming back. Why is there a velocity? How you can see it? How you can see it? Guys, if I were to drop an egg right now from the top of an 80-foot building, what's going to happen at the bottom if it's a raw egg? It's going to splat. My people who are at the North Campus doing the parachutes, the little eggs, the little elementary kids, it's going to splat. If there's nothing else. Well, even hard-boiled is going to splat. 80-foot building if I drop it, right? Okay, pause. Think about it. If you hit the ground with a velocity of 0, think about a car accident. If you were to bump into someone going 0 miles per hour, both of you were going 0. A, it's not possible. And B, would there be any damage?
No.
Two parked cars.
Yeah, right? I don't know, I guess it's like a bump.
There's like an earthquake.
Oh, hey, they're touching and they're moving. They're fine. Okay, so if you could hit with both of them going 0, there's no damage. What makes damage? You hit going at speed, right? What makes the egg splat? It hit the ground with a speed. Now, speed would be a positive. Okay, fine. With a velocity, either way. One of the most common mistakes is thinking hit the ground means, oh, the speed's 0. No, after it hits the ground, the speed's 0 and it's all busted, but not before.
All right.
Or not at the instant of. All right, all good things and all common mistakes. Talk about that. That was fun. Talk about that. That was fun. Oh, look at that. We should go peek at that. We should go peek at that. But first, can you guys try this multiple choice, the long word problem one, and prove to me that you're not going to freak out and give up at homework?
Do it.
Just do it in your notes. That's okay.
Yeah.
Just remind me that when we do this one tomorrow, we'll have to do it in the back. I need to give you another word problem without me talking and distracting and I don't know, talking about instantaneous.
Instant.
It doesn't look fake. I need to change my name.
Stop!
Adderall.
Why don't you just go buy it?
Okay. Adderall.
Sorry. She tried to take it from me.
Hey, stop. You yourself and you in the word problem. You're not going to have people, I don't know, giving you comic relief in homework. Proves to me you're going to keep going. See if I have heart attack. Hamlet, I have Alexander Schwarzman. 1984. Nope, no heart attack. Sorry. Kids read books and then I save them and then if you want them for free. What? Look at this pie. Here's good. No, it's good. AP calculus. If there are pies or if there are radicals in the answer, that is not a calculator problem. Calculator problems are decimals and decimals only. Well, unless they're whole numbers. Are you freaking out over a little bit? You circle. It's a thing. But why? Because you don't know forever card number 11 yet? No. The quiz is tomorrow. It's okay. I'm not judging. I'm just saying, like, is that why? Because what's on forever card number 11?
No, it's average velocity.
Yeah, there's a formula for it. And it even has an S in it. Like this one has an S. Sometimes it changes.
This one was not bad.
It was not bad, I lied.
It's not as good as Drea.
It's not bad if you know your units are
It
cool.
sounds so much better.
I see.
It's a unit circle. Come on.
Where's the answer that I want?
You might have to make it match.
Wait and see if it's unicycle.
If you have any answers, put a little thumbs up on your desk. Just rest it. Just, it's fine. Sneaky.
Miss D, if I do a flip in
Confidential.
class, can I get a pass on this question?
You get a what?
If I do a flip in class, can I get a
So
pass
Miss
on this
D,
question?
Miss D.
You're asking me to pass on the unit circle. That's a no.
I passed it.
I mean, I do too. I'll give you normal.
What's cosine?
Oh,
flip.
Miss D. Oh, what? Are you kidding me? It's the same as cosine of
Five.
0.
If you do not know how to do cosine of 2 pi, that means the cheater chart's not working for you and the circle we think is not working for you. Can we think about the graph? What does cosine look like?
Did it?
Doesn't it look like that? Right, cosine at the curve.
Yeah.
Isn't 2 pi at the end of him?
Yes.
Where is he? He's at 1.
And also think it's also
I just said one.
Where's sine of 2 pi?
0.
Sometimes the graph is easier than the circle or the chart. I'm not saying always, but sometimes. We can go to pi, we can go to pi over 2, 3 pi over 2, we can go to pi over 2 and pi and 3 pi over 2.
hello.
2 pi over pi is 2. Are you killing a seal or are you distributing?
No, we just did it. Miss D.
You're just sitting here. You're supposed to be
It's
selling.
turtles. Let's get it. Let's go, girl.
Wait, you actually say SK? Is that a thing?
No,
Well,
it's just Kyle's thing.
No, there's a TikTok.
It's
It's a TikTok. It goes, "Do I dream from my little straw?" That's the story. I'm gonna tell. You know you love me. SK, SK, disco girl. First Gossip Girl is the XOXO Gossip Girl.
Come on,
Kyle.
What? What did you say?
So what's cosine of 2 pi?
That's 1.
What's sine of 2 pi?
Uncultured
Isn't it 2?
I literally tried watching.
Sine of pi is negative 1.
D.
Okay, cosine of pi. What's cosine of 0?
1.
1. What's sine of 0?
Oh, I know.
0.
Sine of 2 plus 2 is 4 and 4 plus 4 is 8. Woo, I got it. Now guys, if this was a long answer, I would just like box. No, you have to do your trig, but then you can box it and be done. Like literally an FRQ, I would get these numbers and then box it and then be like dun 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 dun. Ha. Well, but the units. But guys, we have to make it match. We have no options.
Just keep going.
Because that's going to be a 2 and that's going to be a 4 and that's 6. All over 2 pi, which is going to be 2 over 2 pi. Oh my goodness, it's just 1 over pi. And if it was a long answer, I would put meters per second. But what did you notice that I did not do? Velocity, it's a derivative. Not this one.
It's average.
It's an average velocity. Average velocity, I just do change in position to get how the meters changed over those 2 pi seconds. Over change in time. Meters per second. Go find the change in meters, go find the change in time. Guys, there was a huge paragraph of information, but was it really daunting if you knew the formulas in your unit circle? Shouldn't have been. If you knew your formulas in the unit circle. Okay, to that end, let's go ahead and peek at homework. So homework, section 2.2. Let's go back. Ooh, we get to go to product and quotient rules tomorrow. All right, here we go. I'm sorry, I don't have my webcam open yet. Webcam. Section 2.2, do you guys have the homework written down yet? I think I have them circled. I think your homework starts on number 89. Ooh, which is a pink problem. My people who don't access their videos, maybe you should start. Oh, sorry, let's shed some light on the problem.
I did. No, I
You
didn't.
guys have 89, 92, and 93? Is that true?
Oh, 89.
I have all circles. Kyle. Just kidding. You said my name and I
I
don't
said
know why.
mine doesn't work. I tried CalcAB and then the video stops up for a few seconds and then my whole app.
And it explodes.
Go on
Then
Snapchat.
maybe don't.
Snapchat, scan it, and then open the window.
Yeah, maybe just delete that. The app's not working. You can go to what would that be under? Like Safari or Chrome?
I
Put it
know.
on the camera.
I
Like,
am.
you just click
Oh yeah, you
on
can
it.
go to any camera application.
Just do the QR code and forget the app. I guess apps.
Just scan it.
Kiddos, we're not going to necessarily do these problems. I'm just preparing you for these problems. So 89, 92, and 93.
What? What?
Summarize for me the paragraph of information.
Find
Find
the
average rate of
ARC
change.
Fn given numeral compare.
Okay, so how are we supposed to do it?
Use
Break it down. Yeah, use what?
average.
Okay. But in this one, I don't have S's. So like at number 89, what's the video going to show me? I'm going to be doing F of, good. Just wait for it. It's still coming. I'm having faith. There you go. F of 2 minus F of 1, all over 2 minus 1. Oh, that's it? The whole paragraph. Just do that, done?
No. Compare.
So can't I say find AVG rate, right? Average. We can summarize. Find the average rate. That's good. And then compare to rates. Why is there more than one? I thought we just plug in, oh, we have two things, don't we? So I'm going to go ahead and find the average rate for number 89. And I'm going to go ahead and take F prime of 1 versus F prime of 2. Now, what am I doing? Remember the whole water balloon problem? Actually trying to understand what's going on. This is saying between 1 and 2, on average, how fast?
Very fast.
What's this saying? At 1, how fast? And at 2, how fast? Right? So let's say you're driving. And you see a cop car. What's the majority of the population do?
Slow down.
Slow down. Okay. So if the cop car's little radar gun takes a little bit of time, which I don't honestly know, I need to learn how a radar gun works. I'm not really sure. Let's just assume that a radar gun can't do calculus, so it actually takes a little bit of time, probably a very small amount of time. But let's just say it takes a little bit of time. And on average, you were going something like 65. Let's just pretend. On average, you were going 65. Is it important for that cop car to know how fast you were going at the beginning versus the end? And could they be very different than the 65? To go 65, could you have been going 90 and then you slowed all the way down to 40? Or something similar. I'm just joking. But yeah, right? Okay. That's what you're doing here. You're saying on average. But that's just like an overview. How fast were you actually going? How fast were you actually going? Maybe they're all super similar. Or maybe depending on the function, these could be very different than that guy. Okay. That's 89, that's 92, and that's 93. I'm going to throw in some fun like ease and some fun trig just because unit circle is a thing. I keep on trying to tell you about that. But let's see where homework goes after that, because so far it doesn't look that scary, does it? What comes next? Number 97. Oh, it's something before that. Number 96. There's something before that. Number 95. Okay, there we go.
Is thrown or dropped?
Ah! There's no equation! Lame.
Make one.
Did they give it to
Read the
you?
directions, yeah, because we would have read it. We would have written it down because we're smart like that, right? Okay. But hold on.
Initial.
Ah! That's initial velocity.
Was that your motto?
Yeah.
Good job.
And then what's this one going to be? Initial position, right? Well, how do we know that? I know initial position for 95. Isn't the initial height going to be 1,362 feet? Because that's where you're, well, let's just pretend you're lying on the building. Don't think too much. You're not throwing it though, you're dropping it. Why did they say dropping instead of throwing? With the throwing one, there was an initial velocity and they gave it to us. Why are they telling me initial velocity if I'm dropping it? 0. Because you're not thrusting it in either direction. You're literally just saying, go with God. Right? So, put me back. What's your initial velocity whenever you see the word drop? 0. So then I have an equation, and from that equation, got it. How am I gonna? Because if I plug in, I have him, right?
Yeah.
How am I gonna do him? That's not talking about initial. That's talking about velocity function. Velocity function is solved by.
It depends which one's
Because it's not average.
Because we haven't gotten anything. But this one, Andre, for that one, plug in what you get because you're done, right? But for velocity, we have to take the derivative. Which, wait, isn't the derivative of this always going to be negative 32t plus, isn't that just a constant? Like 2t or 5t or 6t? No. This one's going to be the actual constant. But then, Adam, what's the derivative of that constant going to be? He has a t, so he stays. But that guy, I didn't actually plug in. I was just saying in general. And then we have something for that, we have something for that, and then we have something for, oh yeah, reach the ground. Remember, what do we know about reaching the ground?
Finding the x-intercept.
Finding the x-intercept, which means set y equal to 0. What's the x in this position? The position function. I need the height to equal 0. Right? The y equals 0 or the height equals 0. Does that make sense? Will it have a velocity at impact? Yes, we do. Yes, we do. Anything that strikes anything, whether it's some sort of. If we're in a vacuum, if we're in like a frictionless space, maybe not, but otherwise, no. There is not going to be a velocity of 0 at impact because the whole point is it impacts. It has a slap, right? Okay. If your velocity was 0 when you hit the ground, I wouldn't mind escaping. Okay, 96. Super similar, right? They just ask things like velocity after 3 seconds. I think that's a T to plug into V, and then. Hey, if it says falling, there are 3 main ideas of motion: position, velocity, acceleration. A quantity, its rate of change, and its rate. If you see falling 108 feet, which category does that fit into? 108 feet is talking about the how fast or the how fast, or the how fast or the position.
How fast?
Position.
Yeah, it's just feet. You see it? It's just where. That's it.
Where?
It's just
Where
where.
are you?
But then it's asking about the how fast with a hint of the where. So if you look at your position and then somehow go to your velocity, you're going to be kind of going in between. Maybe using the where to help you get to a T, to get to the V, to get to the Guys, the only difference down here is that, wait a minute, why are they now saying that the equation is different? Does gravity just magically change sometimes?
No.
Well, depending on where you are, actually does change very slightly. Or where you are in the solar system, definitely. But this is measuring in meters per second squared, not feet per second squared. It's just a dimensional analysis thing that they're not making you do. They're just saying, hey, it can also look like this if you're dealing with meters. Okay, keep going. How about number 99? What am I trying to do? Keep you from giving up on homework. You're welcome. How about number 99 and 102? What do they give you now? Graphs. Now pause. Pause. Do you need to pay attention to what the graphs are? Yes. Guess what comes on the next page after all of this? Word problems. That you are going to summarize the important information, read carefully the directions or the problems, try to write mathematical statements that will lead you to solving. Do the best you can, but come tomorrow with those questions. When you submit it on Google Classroom, should I see any problems with absolutely nothing written? No. I should see summaries, I should see pictures, I should see it. Okay. If you grab coffee for the road, please don't spill it. Anyone? Or in any classrooms. There are a couple donut holes if you guys want to keep those pre-cal kids from enjoying them. We'll get them now. Go forth with that positive velocity.
You know what?